be speaking about coordination compounds and their bonding. So to explain the concepts, I have chosen 3 examples. One of them is chromium H2O6 3+. This is the first one. So here, in this complex, we have a central metal ion, which in this case is chromium 3+. And this is surrounded by water molecules on all sides, 6 water molecules. So the central metal ion is the electron donor, and the water molecules which surround the central metal ion are, the chromium ion is electron acceptor. And the water molecules are called ligands, and they are electron donors. So instead of water molecules, you can have other small molecules like carbon monoxide. You can have ions like cyanide, chloride, fluoride, and so on. These are all ligands which donate electrons to the central metal ion. So in order to understand the bonding, let's begin with electronic configuration of chromium. Chromium atomic number 24. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Now here 4s2 3d4 is less stable than 4s1 3d5, because in 4s1 3d5 the d orbitals are half full. So this is the preferred configuration. So I can write this also as argon 4s1 3d5. Okay, now if I remove 3 electrons to form chromium 3+, then the electronic configuration of chromium 3+ will be argon 4s0 3d4. Right? No, 3d3 and 4p0. So we can see from here that we have one s orbital which is vacant. Then we have 2 3d orbitals which are vacant. 3 of them have an electron and the remaining 2 are vacant. Total number of d orbitals are 5. And we have 3 4p orbitals that are vacant. So altogether we have 6 orbitals. These will undergo D2 sp3 hybridization to give 6 hybrid orbitals. The hybrid orbitals will be oriented in space as far away from each other as possible. So the structure of the complex will be octahedral. So how does the structure of the octahedral complex look? There is a chromium in the center, chromium 3+. Then there are 4 water molecules in a plane. These big dots represent water molecules. They donate electrons to chromium, and the bonds formed are sigma bonds, and they're coordinate bonds where both the electrons are contributed by water molecules. And then we have one water molecule above the plane and one water molecule below the plane. So this is the structure of an octahedral complex. This is an octahedral complex. Moving on to the next coordinate compound, FeCN6 4-. Cn or cyanide has charge -1, and there are 6 cyanide ligands, which means the charge will be -6, and the overall charge of the complex is 4-. That means Fe will be 2+. Now starting with electronic configuration of Fe26, atomic number 26, this will be argon, 4s2, 3d6. Okay, so now Fe2+ will be argon, 4s0, 3d6, 4p0. Now here cyanide is known as a strong field ligand. So what this means is that it causes the energy levels of the d orbitals to split into 2 energy levels. Or no, let me show it here. 3d6. This will split into 2 energy levels. One of lower energy, which will have 3 orbitals. This is called T2g. And one higher energy level with 2 orbitals, which is called Eg. And not just that, this is known as crystal field splitting. And not just that, it will cause electron pairing in the d orbitals. So here we will have 6 electrons paired up like this. So that means 2 d orbitals will be vacant. So we have one 4s orbital vacant, then we have 2 3d orbitals vacant, and we have 3 4p orbitals vacant. So once again we have d2 sp3 hybridization, and we have 6 hybrid orbitals and an octahedral geometry. So how will the structure of the complex look? Fe2+ in the center, then cyanide, 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 cyanide. 4 cyanide ligands in one plane. 1 cyanide ligand above the plane and 1 cyanide ligand below the plane. So this is how the complex will look. Octahedral structure. The last example, here again we have Fe2+, which is argon, 4s2, 3d6. (4p0). Sorry, Fe2+ will be 4s0. Okay. Now here, water is a weak field ligand. Which means it does cause crystal field splitting, but no electron pairing. There's small difference between T2g and Eg orbitals and no electron pairing. So if there's no electron pairing, then the d orbitals are all occupied. So s and p together, these are 3 and this is 1. So we get sp3 hybridization to get 4 hybrid orbitals, and the structure is tetrahedral. Tetrahedral. So here we have Fe2 plus and tetrahedral structure O, 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 O. So this is the tetrahedral structure. Complex will look like this. Tetrahedral. Thank you very much.